All right. Now let's look at this problem right here. Now this is example number 22. I want to calculate the electric field with two charges. Now, if we look at this example very carefully, so we have two charges, Q1 and Q2. The first thing that I want to notice is that Q1 is a positive charge and Q2 is a negative charge. And we said that whenever you have a positive charge, the electric field line is pointing out. And the negative charge, the electric field is more like an attractive force. So let's suppose that I want to calculate my electric field vector, right? So I can say that, now just looking at this picture here, I can say that my electric field vector so first, I calculate the magnitude of vector E1. And then I write it as now, do you guys see where the cosine and the sine come from? Because E1 makes this angle phi with respect to the x-axis. So I can write the x and y components as cosine of phi plus sine of phi. And then I have plus magnitude of vector E2. So E2 is the electric field from charge number 2. Now when I write this direction here, it's going to be negative cosine. Sorry, this is plus cosine here minus. Now look at this vector here. This vector, the x and the y components are greater than 0. But if you look at this vector here, the x component is greater than 0, the y component is less than 0. That's why you have a negative sign right there. So all what I need to do now is to calculate my magnitude of E1. To calculate magnitude of E1, I need to know my distances. So I need to find this distance R1 and this distance here R2, which I can calculate those distances since we know what the angle is. So if I just scroll down to this next slide here, so let's see how E1 has been calculated. So we're going to say that the distance from here to here is equals to y. So that means that R1 squared is equals to A squared plus Y squared. And then you simply write this into X and Y components. So that's your E1 vector right there. And this is your E2 vector. So if you sum those two vectors, you can write your electric field has this X component and this Y component, right? Now, it looks like it is something that is complicated, but it's a very easy problem if you just, if you sit down very carefully with, trigonometry, make sure that you have your angles correctly. So it's not a very complicated problem. Is there any questions about this?
So there's nothing at P, it's just like a spot.
It's just a spot, right. It's just a spot. Now, again, so you can see that, now maybe if this was something like an exam, I could say part A, calculate the electric field at point P. Then maybe for part B, we're going to put a test charge Q naught at that point, and then multiply Q naught by the electric field to get the force. Does that make sense? So the first part is to get the electric field at that point. There is nothing at point P. Then later we're going to introduce a test charge Q naught at that point. Then the electric field is going to cause that charge to move. How is it going to move? Is it going to move up or down? It depends on the Q naught. So if Q naught is positive, so this would be, so the force is going to be pointing like that. So if Q naught is positive, the force is pointing like that. If Q naught is positive, negative, the force is pointing like that. Okay, so this is basically the same problem. So now we've just made a simplification where we're saying that what happens if we take the two charges to have the same magnitude and we take the distances to be the same, then everything is going to simplify in such a way that in this case, you can see that EY is going to be equal to 0. And so you only have an X component, which is given by this value here. So you can, so in this example here, the electric field is pointing in the X direction. So it means that if Q naught, if you take the test charge at Q, which is great, a positive charge, and place it at this point, the force is going to be acting that direction like that. All right, now let's see. So finally here, we're just saying that what happens when, so what if this point P is very, so it's placed at a very large distance. So that we're saying that the height from here to here, which is Y. So Y is way bigger than A, where A is this distance. Then under this approximation here, we can say that this electric field becomes that. So I'm saying that, so when Y squared is way bigger than A squared, then it means that Y squared plus A squared is just approximately equals to Y squared. So if you just forget about this term here, then you take Y squared. So Y squared raised to the power 3/2 is the square root of Y squared, right? Which is Y. And then if you take that to the power of 3, you just get Y cubed. So that's how you get this term right here. So you just forget about this A squared and just focus on that.